Hello, we're going to have a short video today about objective 9.3, which is finding the volume of an object created by rotating an area around a vertical line. This is going to be similar to the last one, but it's got a different formula. So when you take an object and you rotate it around a vertical line, a vertical line rotated around another vertical line will make kind of the outside of a cylinder. The formula for that is 2 pi rh, and the height is the function value, f of x, because that's a y, and the radius is just x. Sorry, I know that's a little hard to see in there. But basically, every time we do this, we're going to be using the formula for the outside of a cylinder, which is 2 pi, and then the integral of the radius times the height. And the radius, again, we just said was x, and the height is f of x. So this is going to be 2 pi integral of x f of x dx. So that x represents the radius. When the radius gets longer or shorter, that x will change. And the height is represented by f of x. So if that gets longer or shorter, the f of x will change. So you're going to see just 4 examples here. Our first one is volume created when this function is revolved around the y-axis from 1 to 3. So these problems always start by putting a 2 pi followed by the integral symbol. In this case, we're integrating from 1 to 3. And since it's just revolving around the y-axis, our formula just will have an x there to represent the radius. And then the height will be whatever f of x is, so 2x minus 7 dx. We're not going to do anything else to this, but if you needed to actually integrate it, you would probably just distribute in the x, and then you could. The next question is the exact same thing, except it's revolved around the line x equals negative 2. X equals negative 2, if you go back to this picture, well, if that's the y-axis, x equals negative 2 is a little bit farther over, which means the radius has increased by 2. So it would create something that's a bigger side of a cylinder. Which means, which of these things is going to change? Well, the radius is going to go up by 2. The height didn't go up at all. It's just revolving around a farther line. So our integral is going to be almost the exact same. 2 pi, integral from 1 to 3. This time, our radius is going to be x plus 2 instead of just x because it's increased by a value of 2. And then 2x minus 7 is still the function value. Again, if you wanted to integrate this, you could. You'd have to FOIL it out first, but that's just time. Our next example is the same idea. We would set this up 2 pi integral from, let's see, they said 0 to 1. X is our radius. It's revolving around the y-axis, so that would just say x. And then our function value is x cubed dx. If you wanted to integrate, you could. You'd have to turn that into x to the 4th first. In our second example, again, we have a change. This time it's rotating around a line that's farther away. So again, we'd have 2 pi integral from 0 to 1. And our radius is going to increase by 2 because x minus 2 is 2 units farther than the y-axis was. And then our function value is still x cubed. These should look very similar. It's meant to parallel. There's going to be a couple more slight nuanced differences of questions you could be asked, but this covers most of this objective. So our objective today was to find the volume of objects created by rotating an area around a vertical line, which could be the y-axis or a different vertical line such as x equals negative 2.